Hello, hello, hello. This is 5.1 right-angled trigonometry, lesson number 2. And here we're going to find missing sides. That is what this lesson is all about. And we're going to do the same thing in lesson 3 as well, by the way. This is very important. So we'll take our time with it. So relax. I know lesson number 1, so much content, all this stuff going on. This one, fewer ideas, just how you do it. This lesson's all about how we're going to do it. The ideas were all yesterday. So I'm going to make myself smaller, and we're going to get this and focus here on the maths, make myself smaller and make that bigger. We've got 3 examples here. They're in your textbook, pages 174 and 175, and I just want to do them here. What we're doing in this topic is we're finding missing sides, missing angles. This time we've got a missing x. So I'm just going to redraw it again there. I've got a right angle triangle. That's a terrible triangle, so let's try a bit better. There we go. Most important thing, it's got the right angle. You can't do anything at this stage if there's no right angle. And there's 38 degrees in that corner. Now, we've got x and we've got 7. So what we're going to do is we're going to, step number 1, label our sides. Hypotenuse, adjacent, opposite. The hypotenuse is opposite the right angle, so that one's over there. The adjacent is right next to the angle, so that's one's down there. It's the adjacent side. Opposite is on the other side. So in order to find x, we're going to use one of sine, cos, or tan. So we've got SOHCAHTOA. So you can write it like this, or you can write it like this, SOHCAHTOA. And you're going to pick one of them, sine, cos, or tan. So what I see here is we know the 7 here. We've got that one. And we want the x. So those are the 2 sides we're interested in. We don't care about the adjacent for this one. We just, not important. We only care about opposite and hypotenuse. So we say, do we use sine, cos, or tan? Well, which one of them has the O and the H? And the one that has the O and the H is most definitely the sine. So therefore, what I'm going to do is I'm going to write sine of 38 degrees, or even this is good enough, is equal to the opposite over the hypotenuse. The opposite is x, and the hypotenuse is 7. So this is substituting. Sine 38 is x on 7. Now, early in the year and previous years, we did some equations. And in order to find x, we need to get x by itself. And what I'm going to do here is I'm going to multiply both sides by 7 to get rid of that 7 there. Times that by 7, times that by 7. Then you'll end up x by itself over here, and you'll have 7 sine 38. We don't normally write the times, but I just put that in there. And now this is the point where you're going to use a calculator. What is 7 sine 38? Top of my head, you can take a guess. You can look at the triangle and be like, oh, it's the side, it's going to be less than 7. It's 38 degrees, around 3. But you're going to actually use your calculator. I'm using Google. Doesn't matter. And we'll get an answer of, oh, I was way off. Oh, it's all the way down 2. Yeah, silly me. So we have an answer of 2, and I'm going to write out the full thing because it's very long. X is equal to 2.07458005097. It'll just go on forever and ever and ever. But normally we only want it to 2 decimal places. The question will tell you how many decimal places it wants. 2.07, and I'll put in brackets to 2dp. So that's what we're doing today. We're learning this process. It's quite long, right? So that's what we're going to do a few examples. You start off with a triangle, label the sides, identify sine, cos, or tan, and then go through the process. So we'll do another one. Keep on going. I got to be careful. The lesson's not too slow so that you fall asleep, but not too fast that you go, oh my God, I'm so confused. A bit of a balance there. So B, we've got a right angle triangle, X4 and 42. So X4, and I'll do it on the same angle here. Close enough. X4 and 42 degrees. Got it right? X4, 42. Right angle triangle. Step number 1. Going to label our sides. What do we got here? Hypotenuse is all the way over here. And the adjacent is next to the angle. And opposite up here is the X. 1, 2, 3. Now I'm going to write SOHCAHTOA. I think it's a nice thing to do. And I'm going to write it this way because it's nice and visual. It makes things a little bit easier. Put a line so we don't get confused. New question. So, which one are we going to use here? Sine, cos, or tan? We don't know the hypotenuse and we don't care about it either. So it's opposite and adjacent. Which one has the A? O and the A? It's tan. So I'm going to write here is tan of 42 degrees is equal to opposite over adjacent. Then we substitute. Opposite is X. Adjacent is 4. Now, a little bit of equations. How do I get X by itself? Times both sides by 4. So we have 4 times tan 42 degrees is equal to X. Calculator. Just typing it over here. 4 tan 42. And this one here, it's all the way up. And that does not seem right. I swear that is that. So I've got an answer here. You have 9, but it can't be 9 because it should be about the same. And I know why. They put it in a different unit called radians. That's for later. So you've got to make sure your calculator's in the degrees mode. We'll show that to you in class. 3.6, that's more like it. So we always do a bit of a check. I've got X is equal to 3 point, and it goes on forever. 601 616 7719. Dot, 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 dot. But let's round it off just to 2 decimal places. 3.60. Cool. We'll do one more. Same process. This time, right angle triangle on that angle, X 10, 24 degrees. I've already forgotten. There it is. I was choosing the colors and I just forgot. X. Oh, that's not a right angle, but I'll pretend it is. X 10 and 24 degrees. So step number 1. What sides we got? We have here hypotenuse, adjacent, opposite. I'm going to write SOHCAHTOA. Just help me prevent mistakes, help you learn. Which one is it? Okay, we don't care about the opposite here. We just don't care about it. We care about adjacent and hypotenuse. That's A and the H. That is our cos. So this time, cos. So now we write it all out. I'm going to go multicolor. Cos of 24 degrees is equal to adjacent over the hypotenuse. So cos of 24 is equal to x over 10 times both sides by 10. 10 cos 24 is equal to x. Calculator. 10 cos 24 in degrees mode, not in radians. That's year 11, year 12 stuff. X is equal to 9.11354 dot dot dot, two decimal places, 9.14. That's our process. That's our process. We're doing the same thing today and tomorrow because it's long, right? And it's new. So it's all about practice and following the steps, following the process. So here's a quick review. What you need to be able to do. You need to be able to recall those definitions of sine, cos, and tan using SOHCAHTOA, or whichever way you remember it. You need to be able to remember that because otherwise, like the calculator doesn't tell you sine is equal to opposite over hypotenuse. You got to know that. Number two, you got to be able to label the sides. Adjacent, opposite, hypotenuse. You got to be able to do that. Step number three, identify which one you need. So for this example, we've got the adjacent, we've got the hypotenuse. That's got to be cos. We definitely need cos for that one because cos of 38 is equal to adjacent over hypotenuse. It's got to be adjacent over hypotenuse, not the other way around. And then form the equation. So we've got cos 38 is equal to y on 12. And then making it the subject. Use your calculator. Round it. Hell of a process, I know. Practice, practice, practice. If you're watching this, you can watch it again. The textbook goes through the same working out. And the questions are exercise 3F, page 175. Questions 1, 2, and 5. Questions 1 and 2 are just intro. Question 5 is all like this. Good luck. Thanks for watching.